All right, everybody, welcome back. If you noticed, I haven't changed shirts since the last video. That's because I'm doing some back-to-back. I'm going to be traveling next couple weeks, so I want to get some of these videos. But we're still feeding these in little snippets on weekly bases because you know I don't want to overwhelm anybody with a lot of content and a lot of time. We're just doing snippets here, snippets there. If you want to watch them in a series, that's what they're built for. So make sure you do that. All right, welcome back. Again, this is based on a series of videos where we're going to start dealing with or working with some NFL special teams data to try to develop a statistic for this. So if you're into sports, into the cloud services, things of that nature, but we're learning along the way. This is the main point: is learning, data sciencey or data engineering processes, but also how to utilize these or take advantage of cloud services so you don't have to go buying expensive GPU computers in order to do this stuff. This is great stuff that the cloud starts to offer or that is offering out there in the world. So good stuff. The first thing that I want to do or go over or introduce in this one, and remember, like, comment if there's something that you don't grasp the concept of, make sure that you ask questions about it in the comments. I'll try to answer as many of those as I possibly can, and maybe even produce more videos on that, on those types of questions in other series or something like that. But again, we're trying to focus on, trying to get this sports statistic out there. So keep that in mind when we're going through this. All right, so up to this point, we've developed a hypothesis, we've created kind of an experiment, we grabbed our data from Kaggle, and in the last video, we introduced Azure storage accounts and how to load data from your local workstation into the cloud without having to log into the portal and do all that kind of stuff. There's different ways that you could do that too. There's programmatic ways through CLI and PowerShell and stuff like that, but we just went right into Storage Explorer and loaded the data in there. So it should be in there. This next part is introducing you to the platform I'm going to utilize to perform the work. Why? Because I don't have a GPU cluster, although I do have a video card on this Surface tablet that I use for this. But I'm already using all my processing power for recording this dang video, so we're going to make sure that we're using their storage, or not storage, but their compute power in that process. Now keep in mind, I'm not planning on editing any of these things, so when I screw up in a voiceover or in, trying to explain something, or you're going to notice that this is real-time errors that we're going to have to navigate through and solve in that process of things. So keep that in mind as we're going through there, which means some videos may be a little bit longer than others, especially when I get into the Python of things, because there's several different ways to do the same thing, and it's been a while since I've done it, so I plan on there being some errors in here. I'm not perfect by any stretch of the imagination, and admittedly, that's the lesson in trying to uh, read the error and solve the problem on your own, which is what we're going to navigate through. And there might be a better way to do it. Post those in the comment too, because again, I'm not perfect by any stretch of the imagination. There's probably a better way to do it than I do. But what we're going to do now is get into, I thought maybe I had, oh, that's because I opened up Chrome and didn't, there we go, there we go, and didn't have it fully maximized. So we're going to open up Chrome, and the reason being is because I already have it set up. I know this is an Azure product, and it's probably optimized to work in Edge. Hopefully there's no user interface or browser restrictions between this and that, but already have it set up. Now, one of the nice things about Azure Synapse Analytics as a service, plus there's no cookies attached to this, so I can show you how to sign in and do all that good stuff, is that this is web-based. So I am logging in. It's this web.azuresynapse.net. Obviously, there's a subscription ID assigned to this, and it's going to have me sign into my account. So I'm going to go ahead and do that. And then I'm going to have to step away for a second because it's going to send me a thing on my phone because I have multi-factor authentication. So give me a second here. I'm not an individual that keeps their phone, on them. I got that 6 foot rule on this. So I have multi-factor authentication. It's going to have me do, an approval on my phone, which I'll go ahead and do right now so that we can get in here. Um, and then I'll go ahead and stay signed in, even though that's going to be the duration of this session. So Synapse Analytics is a web-based user interface. You can see here that it takes me right to a home screen. There's different navigation, like I can go to my data, and that's linked to a workspace data and linked data. I don't have any dedicated SQL pools or uh, things connected in that sense. I usually work with my data lake and when I'm working with this, but you can create dedicated SQL pools, serverless SQL objects, metadata objects in here, and if you want to dive more into that, then you can certainly do that. There's a development tab that can save SQL scripts, custom query language scripts, notebooks, which are IPYNB files, and I also have a Power BI resource so I can actually do visuals. We have the ability to connect Power BI to this, so we can even see our data visually by querying it in Power BI. That may be something that you may be interested in, and we could look at some sports statistics that way. Now that I have all the data, I can set up tables in there and then query them that way. The Integrate tab allows us to create pipelines, and then I can monitor and manage my services. Manage is interesting because the only thing I want to point out in here is that for the purposes of our notebooks, which is going to be the main thing that we're going to utilize, querying or manipulating our data in this case. There's other options in here, but we're going to do notebook-based ones, which are IPYNB files, Python notebook files. But it needs a processor in order to do this. So there's these resources called Apache Spark pools that you can create in Azure Synapse Analytics. And I have a small one, which is basically a 4-core, 32 gig RAM processor, and it's distributed, so it distributes the work out for me and gets it done as quickly as possible, which is great. It's based on, it's got a Spark runtime built into it, and a lot of things that are built into like Databricks, except for like the Databricks proprietary stuff, is already built into here. So I can use the Spark library. I could even use Scala language if I wanted to. I'm not going to for this purpose because I'm not that familiar with Scala and all the functions that I can do to manipulate data with it. But we're still going to utilize the power of the Spark engine and read the data in using the data frame API that's built into Spark rather than a Pandas one, because it's more optimized for that, and that's what we want to utilize in this case. So I could create new ones and get into that whole thing again if you're interested in that. Definitely post that in the comments. Oh, also, by the way, like the video. Tell me what's wrong with the video so I can fix it. Maybe I need to go back and change a couple things to it. I know, like sharing me with the screen, it takes away from the real estate on that. So definitely let me know some of those. If it's that difficult to see, then let me know, and I may add a couple more things on my OBS to increase or maximize the size of the screen while I'm actually demoing things. I guess sometimes it's not ideal to want to look at my face the entire time. I get it. I really get it. All right. It just requires me to create more scenes, and I got so many scenes right now. It's crazy. So we're going to get into this. So in the last video, basically what we did was we had put our folders and files into our data lake. And I have my data lake linked as a service. Now, a link service, you can link several different, like I could create a new, in this case, I can connect external data, and I can go to a storage account, a data lake account, Cosmos DBs. These are the different storage options through Azure. I can also create new link services through, the Manage tab. I can go into link services and create new ones. You can see that I have my data lake, which is my ALDS, my data lake that I created in here, and I have a SQL server that I have connected to this, and a Power BI workspace into here. But in my data, in my link, you can see that I do have my, ooh, did I put that in the right one? I think I did. Yes, because I put it in my training, and you can see here that in that last one, I created that NFL uh, container, right? So now when I get into my workspace, that container's here. And this is the beauty or the awesomeness of Synapse Analytics when I have folders attached to this. So I have the special teams. I guess I didn't really. This is the folder name in here. And some of this, like the archive data, I could probably move up a folder, which I'll probably end up doing after this video. But here's all the folders that I loaded up and the individual ones. Now, what can I do from this? This is where the beauty of Azure Synapse comes in. The individual files, if I right click on this, I can preview the data in here. So I just right click it, I preview the data, and it gives me, you know, like this is the games. So I have 2018 game data in here. There might be more. I think it only puts so many, uh, so much data in the preview. But you can see the game times, the home team, the visitor team. So this is just basic game information. And this is kind of what we're doing in this. So I could rename these files too. The player CS, oops, I don't want to open it up that way. I'll just do a preview again. But you can see that if I double click on it, it pops up a new window that generates or shows the data in here. So you can see player IDs, their height, their weight. This is good information. Their birth date, so I could grab ages from that, their college, their position, and what their name is. And this is back from, I don't know, I think this is current roster information. Obviously, that's all updated every year, but powerful, powerful to kind of relate players, and they have an ID associated with their name, so we can perform joint operations on that. And then obviously there's only 30 something stadiums. So if I preview this, it should show me all the different stadiums in here. So, oh, they're also showing the ones that they do outside of, which is interesting, outside of the United States when they do their away game or when they do those special games in like London or Mexico City and things like that. So apparently they played one in Canada. I don't remember that. They played one in Tokyo, or maybe these are upcoming. I don't know. But I also know that they've played them in Mexico City. There you go. So that one's there for sure. So a couple in Canada. I'm interested to see why they have that information in there. That's probably on their list of things to do for time to come. But some other good information in here. Is it an outdoor stadium? Is it a dome stadium? Sometimes games can be decided on, you know, is it snowing, what the weather's like. So I can also do that. It's also got geographic data, which is cool, and the home time zone in for that. Let's get into the actual nuts and bolts of what our games or our data is going to be utilizing for this. So if I look at the game CSV file, again, this is a game, just the games for this particular data set. So this may fall in line with the ones I already have. And same thing with players. This PFF scouting data, let's take a look at this. So this has a game ID, which is probably going to be our joiner for other, for like games and things like that. The play ID, which for plays would probably join on that. So I'm thinking that this is going to be kind of our fact table in this sense. You can see it's, well, maybe not, because I also have some tracking data that are larger files in here. But snap time, what is this? Operational. It's not giving me the entire name on here. Thought it might do that. Kick direction and some gunners, punt runners, punt rushers. I'm going to have to look up what a gunner is because I've seen that a couple times. Um, Punt rushers, special teams, uh, vises, and kick contacts. I'm going to have to look up some of this stuff because I'm not familiar with some of that. I'm not a special teams coach, so that's interesting how they've identified certain positions and things as like gunners and that information. The players is probably the same. The plays just probably goes over basic play information in here. So I'm assuming this is play ID. Okay, so yeah, plays, play description. Uh, so that's text data. Hmm. You can see here that keywords like touchbacks might be beneficial to pull out of this. Shows you what quarter it happened, what down it happened. Now these are special teams plays, so you can see it's usually going to be a fourth down play. I imagine it's in most cases we're talking about punts and things like that, or field goal opportunities. Yards to go, possession, special teams. Okay, so the play type, the result. So it already pulled that data from that, so that's good. I may not need that description. The kicker's ID, which matches with the player. The returner's ID, which matches with the player ID. Kick blocker, if there was a block kick, I imagine this would have their player information on there. Yard line side, which means what side of the field was it on? Was it on the Philadelphia side in this case or the Atlanta side? What yard line it was on based on what position they were on in the field. Game clock time, if there was a penalties. Very good information in here. All right. So that's it. So let's take a look at this tracking data. I'm just going to preview one because it looks like it probably contains the same information. So these are coordinates. This X, Y, S, and A. I'm going to have to look at the Kaggle and maybe make note references to this a little bit later on. This DIS, the O, the direction, I imagine is a degree. The event, NFL ID, which looks like it's the kicker ID in this case. Jersey number, team, frame ID, game ID, play direction. So that's this looks like it has to do specifically with the kick data, like where it started, where it ended up, the degrees of direction it went. I believe one of them is the height that the ball carried, things of that information. One thing that I am missing on this is how many points a special team scored. So maybe, I don't know if the game's data has the final score in here. No, it just has the data in there. And I don't think that the plays, well, I don't think that the plays has the final. No. So this is basic information here. I may have to pull some other data from somewhere else because I think the way that I want to work this is getting like average points or something like that. I got to have a target value in order to start utilizing data, and it's a target value can't just be like touchbacks and things like that because every team does that. I think it has to be on did the team win or lose, or how many points were scored average by special teams, which can impact a game. Special teams includes field goals and extra points. So those types of points do make a difference in the total amount of data that's involved. So you can see here that what I can do with this, with Azure Synapse Analytics, is I can connect to my data lake. I can preview the data in here. And some other things that I can do is like load data, utilizing what's called a serverless SQL pool. So let's take a look at that real quick, just so you understand the concept of this. I'm going to take a smaller file like this games one because remember I'm putting a GET request in here. So if I do a new SQL script and I use select top 100 rows, then what this does is it opens up my serverless SQL pool. Now, serverless SQL pool is a compute that stands alone, and basically it uses a T-SQL command called open row set to pull data from an external data source. That's what open row set does. In this case, we're connecting to my data lake in a CSV format and loading the information in here. There's some other information that I could create out of this. I could also create external objects, like if I wanted to create a table to start, performing join operations on. In that sense, I could. So if I'm just going to collect the top 100 rows, I can run this real quick, and it's going to connect to that serverless SQL pool, and then eventually spit out a result. Now, I didn't include the headers on this, so if I put headers equal true, then or I think it's like first row, if I remember right, I'll have to show that. So, or data start, or one of those options that are in here, I can change that in my functions in here and define that as my header information. Let's look that up real quick. So open row set T-SQL. Let's see. Just the options in here. I'm trying to remember. First row. This is it right here. So I want first row. And if I go in here and I hit enter and I paste that in here. Now this takes a value. So if I put first row equals 2, meaning what this is telling the open row set function now is that my first row is the second row, and I run this, it's going to apply the first row. Ooh, parser version. Oh, that's because I didn't add a comma. Oh, it didn't add the header. Let's see. Function, bulk file, providing table view query, bulk. I was hoping that would give me something else, but it did name the headers. I'm probably because I might have to apply the scheme to this as I'm going through here. But you can see that it pulls out the information. I can tell you that that's play or game ID, year, week. I would imagine these are weeks, the season, game time, start, and the teams. I can also view this as a chart if I wanted to. That isn't going to make any sense for this, but I can, with the serverless SQL pool, I can call out um, the chart values and change, axes values, and even save the image and put it in reports if I wanted to do that. But the point purpose of this was to kind of give you an idea of what the the power of querying data from a data lake instead of bringing it into like a SQL server in order to perform these type of operations on there. But you can see that first row, I have at least identified that second one as the second row as the starting data, and I was hoping that maybe they put the ability to use that first row as the header in here, but I don't see that operation unless I'm missing something in here. So that kind of shows you how to pull this data in, and this is what we're going to utilize for this. Now, when I want to, say, pull data in from what we're going to use in a notebook perspective, I mentioned that Spark pool, right? So let me get rid of the SQL script. I'm going to discard these changes. I don't like to have all my windows open up on here. So let's take this same data here, and what I want to do is I'm going to create a new notebook, right, and load it to a data frame. So what this does is this automatically for me, it instantiates, and I'm going to go ahead and attach my Spark pool to this. It obviously needs a compute to run this operation, and it takes a few minutes for this session to start up. So I'm just going to go ahead and hit play now. Actually, I'm going to cancel this right now because I want to. Does that? Okay. Because the header is true in this. So I am going to hit play. But it is attaching a session to it. So it does take some time for it to spin up because this is on-demand compute. So right now what's happening is that Azure's building a cluster of virtual machines essentially to perform the computational operations that are required to this. Now there's a control node that sits on top that basically processes the information. So again, I don't know if you can see this on here, but if I were to build this out, and I don't think you can, so there's no point in doing it on here. Let me open up a whiteboard real quick, and while that's coming out, then we'll open this up and I'll kind of show you what's happening with this while that's spinning up. So let's create a new whiteboard. Thank you for the tip. So in this whiteboard, essentially what we're doing is in a clustered format, there's what is called a control node that sits on the top. And it communicates with what's called a resource negotiator in many cases, or a resource manager. And these two are, if we were, I like to define this as like construction terms. So this would be the on-site, you know, the general contractor in this case. And this may be the, we'll call it the union rep. Okay, so that's the union rep. So the general contractor talks to the union rep. Now, if you're in Texas, this doesn't need to happen because you don't need to have union work in Texas. But if you do require unions, that's kind of the setup here. So the general contractor has the scope of work, and that's what happens, or these jobs are sent to the Spark cluster, and that is sent to the control node, or the general contractor in this case. And the general contractor communicates with the union representative saying, hey, we need, this is the job that we're doing. How much work do we need in order to perform this? Now, this is a generalized term. I don't know how all that works in the real world. And then over on this side, we have our, workers. Worker 1, worker 2, worker 3. And once these two have determined how many workers the job requires, then the control node will deploy the number of workers needed to perform the work. Now when we create our cluster, we define a maximum. So there's going to be that many on standby, whether or not we're using them or not, but we're only getting charged for what we're getting used. So in this case, our control node, and this is like loading a data frame, probably doesn't take that much work because this isn't a very large data set. So in the case of loading our data, the union rep says, well, you only need one worker. All right, control node, let's deploy one worker to perform this work. Now, if it's a larger process, a more complex process, like we're developing some complex models, or maybe even getting into some neural network stuff, that may require GPU enabled, type of clusters, which you can create in Spark, that have things like PyTorch and TensorFlow built into them. But in this case, let's say we perform a job that required 2 or 3 or maybe even, in worker N, and however many that is. So that happens between this resource negotiator and the control node in a distributed workflow. So that's how all that kind of works. Job source dependency, huh? Session failed. Run the notebook to start a new. Okay, so I don't know why the session failed. That sounds like a back-end error to me. We'll see if it runs this time or if I have to figure something out on the Spark side to do something. Maybe set that up and revisit this. But there was some type of token that wasn't being established between the two. It may require me just to delete the old Spark and create a new one. It's been a while since I've used this thing, so it may be that reason. I'm going to go ahead and close this window out. But essentially, this is and to introduce you to the notebook format in Azure Synapse Analytics, which they call a Spark notebook. There's going to be a lot of familiar things if you're used to dealing with notebooks in this case, like being able to run cells once you have all these. You can create markdown cells. You can actually create parameter cells within this. And those are intuitive for attaching them to like workflows or activities and pipelines, because then we can identify those parameter values that we're setting to be dynamic in nature and then apply a parameter to that within the notebook. It's pretty powerful stuff. You can publish these, which then it would go into our development tab once all that happens. This is where you would identify, you can create several different sizes of Spark clusters and different Spark clusters for different for different purposes, like I mentioned, GPU or whatever. So hold on, I don't know what's happening with this Spark cluster. It may require me to make a new one. So, oops, I don't want a link service. Cancel. I want a new Spark pool. We'll call it Spark tool. I don't want it isolated. We'll call it small, and 3 to 10 is fine. That's fine. Create this, and I don't think it takes too long to create the cluster, but that is a little strange that that's not running. But to continue on through the notebook, right? So we have the ability to add comments to things, which is great. Now, when you create markdown cells, so what I could do is I could add a markdown cell here, and this is basically like HTML format. So I could use bold or italics and things like that, and I could write above cell loads data into data frame, if I spell it right. And I could make this bold if I wanted to, and it adds the HTML type, operation to do this. So when I click out of it, it's basically like adding notes into here. So we'll probably be doing this. There we go. Spark 2. Let's see if this one works. It may have been something else. I'm going to delete this just to connect that, but that token, it had something to do with the token, and I don't know if that has to do with my permission. I shouldn't have anything to do with my permissions in here, but it's something we may take a look at. If there's also the ability to utilize a version of Azure Data Factory into this, and one of those activities could be to import or utilize a notebook as an activity step. So if I have a data processing solution in a notebook, I can add it as a step in the process and add it to a pipeline from here. And then I can view the properties of this, which I could rename this load into notebook, and if I were to publish it, it would come into my notebooks here. And I can clear my outputs and do some other things in here, manage my sessions. It looks like this one might actually be doing something for me. I may have to delete that other Spark cluster. There might have been something that happened with that. But we'll see if the session starts. It looks like it may be connecting to it this time. If not, then it might have something to do with my Synapse Analytics workspace, which hopefully is not the case. But within this cell, if you're familiar with Python, Another cool thing about these notebook formats in Azure Synapse Analytics is that I can choose what language I want to set as my default, and then I can change my languages on a cell-to-cell basis. So PySpark is basically Python utilizing Spark engine tools. And then they have Scala, which is the language of Spark, so they call it Spark. You can also use C Sharp if you're more familiar with Microsoft. I believe F is another one that you can use in the .NET. And then SQL. So I could even utilize SQL. Now there is a nuance to this. It's Spark SQL, so you would have to use like SQL context commands, or you would literally have to create a temporary table in order to use like T-SQL type statements in order to do this. But that's something you can do. Now, how to instantiate those in different cells, like this one, it's called a magic operator, and you can see here that it applies the magic operator automatically into the cell. So if I wanted to create a new code cell, I think it doesn't add the magic operator in here, but it knows to use, in this cell, it's using Spark. I could change the language then if I wanted to put %%, and you can also see that this has IntelliSense built into it. So there's different ones I can use. So if I want to use Spark, SQL, or C Sharp, or some of these other ones, time it, write file, these are magic operators, and what that does is it tells it to perform this operation in the rest of the cell. So I could change it to Scala in this, and then start writing Scala commands after I've loaded into a data frame. Now I could do that because Scala and PySpark still work with the Spark engine in those cases, but we're not going to do that. Hopefully this Spark session starts. This is usually a good sign when it's taking a little bit longer to connect. Again, what's happening in the back end is that it's building this control node, this resource negotiator, and all of those workers, whether they're going to be performing the work or on standby, it's creating that cluster for me on demand and performing all this in memory. In memory is a big part of notebooks that you should probably be aware of, because if I were to run this and step away, there's a time limit on when this thing will pause. And once this, they call it pausing or termination in other places, but once it's disconnected from the session, anything that was saved in memory, which is everything until you write it to an external file source, is lost. So I would literally have to go back and start this notebook from the very beginning and attach a new session to it if I were to stop and go somewhere and do something while nothing's running in this case. So that's no bueno in most cases, unless you have everything written down and it's going in the order that you want it to go into. So good sign that it's taking this long to actually create the session. And the point and purpose of this is just to show you that you can load data in here. On the next video, what we're going to do is we're actually going to take this data and then we're going to convert it into a different file format that's more optimized for the Spark engine. It is ready. So it was a Spark, or it had something to do with my old setup. I might have to get rid of that old Spark pool, which kind of hurts me right here, but sometimes that happens. So now it's running, and it literally doesn't take long but now it's got to access the data lake and then spit out the information. Once it's in there, then I could, the display doesn't take that long to run. And the display is basically just spitting out a rich HTML format of the results of what I've performed in here. This operation here is instantiating the spark.read, which calls on the data frame API in Spark to return what's called a data frame. And a data frame is basically taking that CSV data and putting it in a table format, rows and columns essentially. So it's more visually familiar to humans in that case. So it's making it so that a human can kind of read the data. And that's why we include the headers are true, because the headers are the first row of the data. And that's what that means, is that it tells it that first row that's included in the CSV file, and that's what it's pulling out of here from a CSV file. We even included that in there. um, that uh, that it's going to spit out the first row as the header values. It's taking a little longer than I wanted to. Hopefully it kicks out the result here in a minute, because the game's data I didn't think was that large. Yeah, it's only 39 kilobytes, so I'm wondering why it's taken so long to actually do this. Ah, there it goes. All right, so there you go. Game ID, season, week, game, date. Um, that took way too long to run that one. But now that it's cached in memory, and basically that's what happens when you convert something into a data frame, that data frame is then cached into memory, and then I could call on this and do some other things. So that's kind of like the introduction to how to utilize serverless SQL pools to query data from a data lake, and how to kind of load data into a data frame so that we can start working with it. So if I start reading in data and then um, performing ETL operations from here, I don't need to know the code to read it in necessarily, but there's probably other options in here that I might need to add in here. Um, if I want to rename columns or do something like that while the data is loading, I can do that as well. And displaying the data just as a sanity check. You always want to perform sanity checks in here. So that will pretty much do it for this video. Again, this one's probably ran a little bit longer than I wanted it to, just because of the errors that got kicked back and the things that I wanted to do. But I wanted to get the point across about introducing you to the service. And again, if you have questions, please feel free to ask those questions in the comments about certain things. And definitely like, subscribe, do what you need to do. I know there's a lot to this, and I know some of you want to get right into the NFL data, and we'll eventually do that. But I want to get everything set up, and I want to take everybody through the learning process of how to utilize these tools in order to, create your own workflows. Things like Synapse Analytics, storage accounts, they don't cost you anything, and a lot of them are free for the first 12 months anyway. Not everything, but they don't cost you anything to create them. It's not until you start using them. Until I load my first file into a storage account, it just sits there and doesn't charge me anything. Same thing with Synapse Analytics. Until I start utilizing the compute power that's in here, the web-based service itself doesn't cost me anything. Or the serverless SQL pool doesn't cost me anything until I call on it, or until I create a data warehouse, or doing other things within here. So until you press buttons and start putting things into services and resources, that's what truly on-demand type of of costing situation, where when you're moving from a capital expenditure situation to a operation expenditure. The first time that I ever when I got into data science, when I got into data science, it was like, oh man, I need a uh, NVIDIA processor, GPU processor built into my laptop. I want at least 16 gigs RAM in this thing, so that I can start processing my data science jobs, and then I'm going to load the whole environment on here. I am now not doing any of that. I have a development VM where I've installed all the applications, so I don't have to install them on my local workstation. I use cloud services because they're on demand. I didn't have to pay $2,000 up front to utilize this stuff. This will probably cost me, a couple $100 in the long run to utilize over the course of whatever we're going to do with it. It probably won't even be that much. We'll take a look at Cost Manager and see what it does cost us, um, since I can track the costs associated with this. And you may want to do that in the real world. But keep in mind that these are on-demand resources. I can delete these whenever I want to, and then they even hold on to the data for a certain period of time, even after I delete resources or when my account's up or something like that. So I hope you enjoyed the video. Uh, Keep in mind that I'm going to try to kick these out every week, and we're just going to continue through a different concept each time. The next one, what I'm going to do is I'm going to convert this data from CSVs into Parquets because Parquets are more optimized to be read from a Spark engine. And I want to try to reduce my costs as much as possible when I'm reading this data in. So thanks again. Have a great week, and I'll see you on the next one.